Hey, hi everyone. Welcome back to my YouTube channel. My name is Sunny Savita, and I'm back with another exciting and important video. So, guys, in this particular video, we're gonna understand some fundamental concepts of the NLP, and this concept it is directly related to our topic which we are learning currently. So, if you don't know about it, guys, I started with the fine-tuning playlist where I already uploaded 5 videos. So inside the first video, guys, I discuss the complete syllabus of the fine tuning, that what I'm going to discuss. Then I discuss the complete introduction from starting to end. Then I discuss about the transfer learning and the fine tuning, then top LLM fine tuning framework. Now in the previous video, I discussed one more concept with respect to the interview, which could be helpful, and even it will helpful to understand the fundamental regarding the fine tuning RAG and agents and when you need to use which concept. So if you haven't seen this particular video so far, please go and check. It's going to be a very amazing for your learning, for your fundamental and all. Now in this video, guys, we are going to discuss one more very important concept which could be your interview question as well, and intentionally I kept this video inside my fine-tuning playlist so that each and every detail, each and every concept, each and every nitty-gritty thing you can understand. So my topic is going to be for this video, like, was fine tuning possible inside the LSTM model, and what is the differences between the LSTM and the transformer model. Okay, these two things we are going to discuss. Right after this one, guys, I'll discuss about the HuggingFace. I created one very detailed video on top of the HuggingFace. After this video, I'll upload that particular video, and after that I'll come to the fine-tuning concept, how we can fine-tune the classical LM models like BOT, T5 and all, and then we'll discuss about the distillation and the quantization and all, and then the main LLM fine-tuning and all. So in this particular sequence I will go, and after 4 to 5 more videos, you will find out the main fine-tuning video regarding the LLM and all, and this playlist is going to be little longer, so where I will upload around 20 to 25 videos. So I hope, guys, you got the entire context, and you are aligned with my agenda, whatever basically I have. And guys, if you haven't subscribed the channel so far, I would request to you, please subscribe the channel, because I have seen many people are watching a video but they are not subscribing a channel, guys. So if you will subscribe, guys, I will only get a motivation to record more and more video and the content for you, and believe me, guys, I will be coming up with more amazing content which will directly help you to crack any sort of a generative AI or AI interview. Okay, now I hope everything is clear. So without a further delay, let's move to the topic, guys. So topic wise, guys, here only I kept the entire notes. What is the RNN and LSTM? Why fine tuning was not possible? See the entire theoretical notes. Okay, and then what is the differences between the LSTM and transformer? So guys, for this one, what is the differences between the LSTM and transformer? I will record one more specific video. Right after this one, you will get that. But let's try to discuss what is a RNN and LSTM model and why fine tuning was not possible. Not only the theory, guys, I will talk about the practical as well. Here I already created one collab file, and inside this collab itself I am going to write my code, right, regarding the LSTM and all. Okay, each and every idea you will get, guys, don't worry, each and everything I'll be clarify. But before starting with this thing, let me give you the overview that what was the RNN and LSTM model, and I will tell you, guys, whether it is being used or not in a current era, because now it's an era of the LLMs, and hardly we are using this RNN and LSTM model. But to understand the fundamental and to like answer for the interview question, for sure we'll have to go through with this topic as well, because if we won't understand about our past, then we won't be able to understand anything about our present, right, which is a LLM only. So guys, here I kept what is the RNN, okay, and then what was the LSTM, and what was the sequence to sequence model, right? So this three thing will clarify, and after that I'll come to the practical. So we're talking about the RNN. So what is the full form of the RNN, guys? See, again, this RNN could be one of the specific topic. I can record one entire video on top of this RNN, but as of now, I will be just giving the overview so that at least you can understand about the practical and all. Okay, and whatever kind of interview question is coming to you, you can answer those things. So here the thing is, what is a RNN? So the full form of the RNN is recurrent neural network. Okay, so before coming to the recurrent neural network, you will ask to me, Sunny, what is a neural network? So here guys, this is the architecture of the neural network. Okay, now inside the neural network, you can see we have three main layers. The first is called input layer, the second is called hidden layer. Okay, this one, hidden layer. Okay, and the third is called, just a second, yeah, this one is a hidden layer, and the third is called the output layer. Now this hidden layer is nothing, it's a hyperparameter. Okay, means we can have as much as hidden layer inside the neural network. If you are familiar with the basics of the neural network, then definitely you are aware about this particular concept, right? Now guys, what is a RNN? So inside the RNN guys, see, as I told you, neural network is a collection of three things. The first is input, the second is hidden, the third is a output. Okay, now inside the RNN, one more term is going to be involved, that is called a recurrent. Okay, recurrent means what? Recurrency. Recurrency means what? Again, the same thing is happening, right? So the R actually it is representing to the recurrency. Okay, so again the same thing is happening, means whatever output is being generating from this particular layer, from here, okay, again we are passing same output to the hidden layer itself, and this is happening on a sequence basis, right? And this is only is called the recurrency. Okay, again I'm repeating, neural network means input, hidden and output. RNN means recurrent neural network. R is representing to the recurrency, where the recurrency means whatever output is being generated from the hidden layer, again we are passing to the same hidden layer until and unless we are not able to process the entire data. And using this RNN, generally we handle the sequence data. Now you will ask to me, Sunny, what is a sequence data? Sequence data, one of the example of the sequence data is a text. Okay, text is there, and audio is there, right? DNA information is there. So those kind of data is called the sequence data, where the sequence matters, right? I have kept the example of it. I'll show you that part. I hope you understood about the neural network and the recurrent neural network. Now guys, whenever we talk about the recurrent neural network, so we've seen this kind of architecture. Okay, so this kind of architecture. Now this is the expandation, and this is the expanded version of this architecture. Okay, now let's try to understand it. So what we do guys, let's say we have a sentence. Okay, any sort of a sentence. Let's say here I, now next is love. Okay, and the next is a mango. So what we are doing, we are passing I, love and mango. See, so we are passing an input. Okay, my input is going to the hidden layer. Now whatever like processing will happen over here, so after processing it guys, again on the next time stamp it will pass to the same hidden layer. Okay, in the same way, see, here only I have shown you. Let's say here you can imagine inside this architecture, let's say I'm passing I over here. Okay, it is going to be processed, and then how it is going to be processed inside the hidden layer itself. Now whatever output we are going to be generate, so this particular output again we are passing to the hidden layer, and at the same time, okay, at timestamp 2, this love is also being passed. Okay, so from here this love will be passed now. Now once the love will be processed, okay, through this hidden layer, again this will be passed to the like hidden layer again, okay, at timestamp 3. And then after this love guys, what is the next word? The mango will be passed. Okay, so from here, from this particular input layer, the mango will be passed, and see, here is a mango. So at first timestamp I will be passed. Okay, and whatever process will happen over here, it will happen. Then this output will be passed to the next hidden layer, sorry, the same hidden layer on the next timestamp. Okay, and the fresh input at timestamp 2. This is and t is equal to 1. This is at t is equal to 2. This is at t is equal to 3. This will be going on as per the sentence length. Okay, so guys, here the at timestamp 2, this love also will be passed, and I will also be come over here. Now it will process, the entire data will be processed, and then this data, this output will be passed to the same hidden layer on the next timestamp. Okay, and here the mango will be passed and the output which is being generated from the past 2 timestamp. I hope you understood this RNN architecture, and mainly we use it for handling the sequence data. So I kept couple of example over here for handling the sequence, like what is our example of the sequence data. You can clearly see over here. The first example of it is a text itself, as I told you. The second is a time series data, where the sequence also matters. Audio speech data is also a example of the also example of the sequence data. Then here whatever basically comes in a sequence, right? Wherever sequence matter, that type of data we can process using the RNN. Okay, now I hope you got the understanding. Now the next thing is why recurrent. Okay, because RNN remember the previous input, okay, previous information, and the pass information from one timestamp to the next timestamp. As I given you the example of this particular sentence, so I love mango. So at first timestamp I will be passed, okay, it will be generating output. Then next timestamp love will be passed, and output from the previous timestamp we are getting output of this love I. Okay, then at the third timestamp this mango will be passed, and here we are getting output from all the two timestamp, right? So this is the simple understanding regarding the RNN. Now guys, if we're talking about the like RNN, in the RNN also you will be able to find out the input layer. Then there will be a hidden state, okay, and then in the hidden state itself actually we are going to be sustain the memory, as I shown you how to do that, and then basically we are going to be generate the output. So this is all about the RNN guys, and this was the like the kind of neural network which we were using for processing the sequence data. But nowadays we have a very advanced model like the transformer kind of model, and the different variant of the transformer. Okay, and even we have a Llama also. You can check out with the Llama. It is a updated like upgraded of the upgraded version of the transformer. Okay, and more than transformer, and maybe it could be the future. I hope you understood about the RNN. Now coming to the next topic. So LSTM is one of them. So guys, this LSTM is nothing. It is a special type of RNN network. So in short, I can say this LSTM actually, it is a updated version of the RNN. Okay. Now one more thing guys, here I'm just giving you the overview of this particular architecture, but there could be a separate section or separate lecture on top of it. And I can take up one series, the NLP series. There only I can discuss all this topic, and soon I'll be starting after completing this particular fine tuning and all. Now whenever we're talking about the LSTM guys, so LSTM again is a special type of RNN, okay, that is designed for handling the sequence data. But guys, in the LSTM we have some like a special thing. So LSTM can remember the long-term information compared to the RNN. RNN struggle to remember the long-term information. Okay, LSTM is going to resolve this particular issue. Like the RNN was not able to sustain the long-term information. So LSTM is going to be resolve this particular issue using this three concepts. The first thing is called the forget gate, second is called the input gate, and the third is called the output gate. Okay, so this two gate actually it's a main one inside the LSTM. The first is a forget one, okay, and here the second is the input gate. In the forget one basically, so we like the purpose of the forget gate is what needs to be forget, okay, kya bhulna hai. The main purpose of the input gate, what needs to be add, okay, what new thing is going to be add, the new one. All right, and what is the purpose of the output gate? What needs to be passed as the output to the next time stamp. So this is the cell, this is the unit, the LSTM unit. Here you can see this is the same thing like the RNN itself. So we are passing input, okay, and here we are getting a output from the previous hidden state, and it is processing. But apart from this one guys, you will be able to find out one more cell over here, that is a hidden one. Sorry, this is the memory cell. Okay, and this input and this memory cell, it is connected to each other via this three gate. The first gate is called the forget gate. Okay, this particular gate is called the input gate. Okay, and this particular gate is called the output gate. So it is similar to the RNN only. This one, we are passing input at a timestamp, and we are getting something from the previous timestamp, from the hidden state itself. But this thing is connected to memory cell. This is called a memory cell for sustaining a long-term memory. Okay, with this three gate. First is the forget gate, second is the input gate, and third is the output gate. And finally, we are getting a output. See, Likewise, we'll be having a multiple units, okay, in a different time stamp. If you want to understand about the this LSTM, guys, you can go and check with this particular article. It is a very good article. On top of the LSTM, you will get a very like a minute detail regarding the LSTM and all, along with the equation, right? So they have brief about the RNN as well as the LSTM, and if you don't know about it, you can go through with it, and you will get some good understanding regarding it. Okay, now coming to the next part. So LSTM you understood. Now what was the differences between the RNN and LSTM? So guys, so see here I written couple of point, and based on this particular point we can identify the differences. Okay, the first one basically memory. So we're talking about the memory, guys. So in RNN, there was a short-term memory, means we cannot remember like more than 10 to 15 words. Okay, the sentence basically which is more than 10 to 15 words, now we won't be able to like process that. Okay, we won't be able to recall that particular sentence. Now, but in LSTM basically we can recall that sentence up to 30 words. Okay, that was an enhancement over there. Handle long-term context, yes, it was not able to handle, but yes, somewhat it is able to manage at that time. Okay, and in 2014 and 15 now, guys, LSTM was on a different level, right? It's structure wise, so simple is architecture of the RNN, but it was a complex because of the gate concept. Then uses today, it is rare, no one using the RNN. LSTM wise, replace via transformer. Even the LSTM is not also being used. Okay, so here I written couple of limitations of the RNN, the basic RNN. So forget the long-term information, vanishing gradient issue was there, and the slow training also was there. And somewhat this problem was encountered with the LSTM also compared to the transformer. That we'll look into the next session. Okay, there I will explain the LSTM versus transformer, and you will understand the clear-cut differences between both. Okay. Now I hope, guys, this each and everything is clear. I just took 15 to 16 minutes to explain this entire thing so that you can enjoy the practical. Now let me discuss this sequence to sequence learning, and then guys, I'll be explaining you what I'll be explaining the practical of it. Okay. Okay, guys. So what's the meaning of the sequence to sequence learning? So sequence to sequence learning means what we are passing as an input and what we are getting as a output. Okay, so in input are we passing sequence, or in output are we get a sequence, right? So that matters over here. Let's try to understand what does it mean. So guys, whenever we're talking about this RNN and LSTM, okay, or this transformer architecture, right? So this architecture actually it was prone to the sequence to sequence learning only. Means we were passing one sequence as an input and we were getting the another sequence as an output. Okay, so let's try to understand what does it mean. So here, guys, you can see this is the example of many to one. Okay, in input you can see we are having a multiple inputs. Okay, it is a sequence itself. You can assume it's a sentence and we are passing single words on a like single time stamp. Okay, so at t is equal to 0 we are passing what, t is equal to 1 we are passing one word, at t is equal to 2 we are passing another word, t is equal to 3, t is equal to 4, and so on and so forth, right? So here you can see this could be RNN or LSTM, and as an output you can see we are just getting one. Okay, we are just getting one word. So this is the example of the text classification, guys. Text classification. You will ask to me, Sunny, what is a text classification? So text classification means in input we are passing text, okay, and in output actually, so this is my input, text means sequence, and in output basically we are just getting whether the text is a positive or negative, or it is basically spam or ham, right? Mail I'm talking about, or basically what does it mean? The text basically what it is trying to represent. Okay, it is a like it belong to which category, right? So we are just going to be categorize the text. Now the second example basically it is sequence to again it is a example of the sequence to sequence, but it is many to many. Okay, what does it mean, guys? So many to many means so we are passing a sequence over here, okay, and we are getting sequence over here. So what could be the example of it? So here the example is a NER. Okay, now inside the NER you can see in the input we are passing text. and in output actually we are getting tag corresponding to each input word, right? So it's a very good example of the NER. Now this is nothing, guys. So this is actually multiple hidden layers. It is representing to the multiple hidden layers. It is the same one actually, many to one, and here is a many to many. Okay. Now guys, one more thing is there. Now whenever we're talking about many to many, okay, so there is a two kind of architecture. So this was the early stage architecture with respect to many to many. Okay, and this was this kind of architecture, guys. This one you can see, right? Either this one or this one. So this is with the one hidden layer and this is with the three hidden layer. Okay, this is called the deep RNN or LSTM. Because whenever we're talking about this early stage architecture, with that we were just able to solve the NER, POS tagging and all. But when this architecture was involved, okay, many to many with the asynchronized length. So in input actually we can pass any sort of a length, and in output we can get any sort of a length. Okay, so using this particular architecture we were able to solve text summarization kind of task. We are able to solve text generation translation kind of task. Okay, and even we were able to handle this text generation kind of task, but with a very limited capability. Okay, so this is also called many. We are passing many words over here and we are generating many words over here. So this is also many to many, but it is asynchronized. Asynchronized. So what does it mean? Asynchronized means different length. In input we can pass different length, okay, and in output actually the length of the output could be a different. Okay, so you can think in such a way, we are passing something over here. Let's say we are passing they are watching something, and we are going to be generate a summary. So for sure the summary length, the output length is going to be something different based on this input. If we are talking about the translation, okay, the translation, let's say I have a Hindi sentence, वो TV देख रहे हैं, so they are watching cricket. So in English actually, the English sentence, there could be a different number of words. Okay, same into the generation as well. Let's say we have passed one sentence and we want to generate the further thing of the like the whether we want to predict the next word or we want to generate a further word. Okay, so in that case also the length is going to be mismatched of the input and the output. Getting my point, guys? So this architecture was very good at that time till 2017, until the transformer was not introduced. Getting my point, guys? Yes or no? I hope many doubt is getting clarified. So if I'm going to summarize the sequence to sequence learning, so using sequence to sequence learning. So sequence to sequence learning is nothing. It is just a way to process the input and output. Okay, just a way to pass an input and getting an output. Okay, through what? Through this RNN and LSTM kind of architecture, right? So we have different type of sequence to sequence learning. The couple of are very famous. Many to one, that represent to text classification. Okay, now the next one is what? Next one actually many to many with synchronize length. Okay, means input and output would be on a same length. So there is an example. I can give the example of it. Let's say NER and POS. The next one, many to many. This also comes under this encoder and decoder architecture, right? The encoder and decoder research paper was published in 2014 itself. Okay, many to many, and this was the asynchronized. Asynchronized means what? Asynchronized means synchro, CRONIZ, right? Asynchronized means what? So the length could be different, the input and the output length could be different, and there actually the summarization, okay, the translation, the generation, this kind of task comes. I hope you understood the entire fundamental now. So earlier we were using the RNN and LSTM. Nowadays we have a transformer model. But guys, this is all the fundamental. Now let's do one thing. Let's try to look into the practical of it, and then we'll see why basically fine tuning was not possible inside this LSTM and the RNN architecture. I will not show you the RNN. I'll just show you the LSTM. So guys, now without wasting a time, let's start with the practical guide. So for the practical guys, we'll have to import couple of libraries. So I already imported this library. See, NumPy is there, transformer is there. Then here I'm going to import the model from the Keras. Okay, yeah, Keras is a part of the transformer TensorFlow itself. So I'm using that same. Then I'm using this import LSTM embedding and dense layer, and then pet sequence. Okay. Now here I am going to be define some parameters. So this I'm going to be used further. So the first is a max length. The max length of the sentence, there will be a 200. There could be 200 character. Then the vocabulary size, whatever data I'm going to be used regarding that it is. Then embedding dimension. Okay, what will be the dimension of the embedding of the particular word? And latent dimension means the hidden layer dimension. Okay. So yes, first what I can do, guys, I can import the data. So I'm going to import the data here. I have importing data. The data basically it's IMDb data. So first I am going to be solve the text classification task. Okay, so let me import the data. I'm just going to be use this trained X train and Y train data. Okay, for the validation and all it is not required. That's why I'm not going to be import the test data. Okay, I'm simply keeping it underscore. Then after that, guys, let me show you the length of it. So I already written a code. I'm just like going to be copy and paste over here because I already prepared the entire solution. So here you can see the solution, like the length of it, the length of the extended Y train is going to be 25,000. So this much is data like very huge. So in that case, what I can do, I can just take a subset of the data, okay, just to train my model. So I'm just taking 3000 rows, the initial 3000 rows. Okay, now if I will check with the length of the data, so I'll get 3000 only. Okay, you can check with the length and length of this X train and Y train, you will get the 3000 only. Now guys, I'm going to perform the padding because if I'm talking about the sentence, guys, so the sentence length could be something different. Okay, so let me show you the X train one. So here is my X train. If I'm going to show you the first sentence, so see, so this is my first sentence. Okay, it is in a number itself. I'll show you the decode. I'll decode this also. Okay, so see, this is the length of the first sentence. So here you can see 280 words is there, but if you will go and check with the second second sentence length, so there could be a different one. So see, here the second length is a 181. So I want to keep it in a same one, so that's why I'm doing a padding. Okay, there I am passing X train, maximum length of the sentence, padding, post padding, and truncation, post truncation. Okay, so padding means we are going to be at 0 at the end of the a sentence. Okay, just to match the sequence. If the sentence length is more than 200, in that case I'm going to be truncate the sentence. Okay, I'm going to be detect the sentence, those specific word. Now here is my extent, guys. Now what I'm doing, I'm just going to be create my model. So see, here is my LSTM model which I'm going to be create. So first is a input layer. So the size of the input is max length, okay, of the sentence. Then here is the embedding, right? So this input layer, actually I'm going to be connect with the embedding layer, and in the embedding, guys, you can see the size of the vocabulary and the embedding dimension. So every word basically we are going to be represent with this particular dimension size. Now this embedding layer I'm going to be connect with the hidden layer. So this is my hidden layer, and how many neurons is there inside the hidden layer? There is a how much, 256 neurons are there in the hidden layer. Okay, then guys, here we are going to be connect this hidden layer, guys, this LSTM dense layer. Okay, with what? With the output layer. Okay, so in the output, actually we just have one output because it is text classification, and see, we have a 3 parameter over here: LSTM layer, hidden state, and the cell state. Okay, if you will look into the LSTM architecture, you will find out this 3 thing itself inside the LSTM cell. I hope you understood it now. Then here, using this model, we are going to be create a model. So this is my final classification model. This is just like simple way of creating a LSTM model using the Keras. Okay, now if you want to check the layer of the classification model, simply you can write classification model dot layer. See, here is all the layers. Okay, input, embedding, output, and all everything. Now if you want to check out the summary, so you can simply call the classical model or summary, and see, this is the summary of the layers. Okay, so in input layer, this is the size of the input layer. This is a trainable parameter of the embedding layer. Then this is a hidden layer. These are the trainable parameter, and this is the output layer. Okay, so total trainable parameter and all everything you can see over here right now. So here I'm going to be compile my model. Let me compile my model, guys. Now after compilation, what I will do, I'll train that. So compilation is there. I am passing my optimizer, loss function, and the matrix, on which matrix I am going to be validate my model on top of the accuracy itself. Okay. So here I'm going to pass the here I'm going to be execute this fit. Okay, classical model dot fit. I'm passing my extend by train best size. The data will go in a batches. I'm just executing one epoch, and here is the validation is split, means 0.1% data is going to be used for the validation. Okay, and on the accuracy basically will be showing you the validation result. So once I will execute it, guys, here you will find out the training of it. So my training is going on now. If you want to check out, guys, so this is a code to check out the model whether everything is perfect or not. Okay, so I'm just taking one first sentence. Okay, and I'm predicting with the model whether it is a positive or negative, so I will get a final output. So let it complete, then only I am going to do that. Now guys, here I written a one more code. Okay, and don't worry guys, this entire code written by me only. I tested first in the different file, then only I am going to be copy and paste. So step by step you can understand everything. Now here you can see, so this is my basically this one is a code just to decode the sentence, because the sentence actually it is in a number. If you want to check the word regarding that, okay, the complete sentence with the natural language, so you can execute this particular code. See here I'm just checking with the first review, sample review only, and let's see what it would be. So here my model training is done. Now if I want to check with the model, so see here you will get the prediction. So prediction of the sentiment is a positive, right? Now if I want to check with this particular sentence, whatever I have passed over there, the sample review, you can see it is in a number itself right now. But guys, if you want to check the actual sentence of it, so you can execute this code. Okay, so here you can see this is the code. Now it is giving me error, IMDb is not defined. Let me check whether I have defined the IMDb or not. So IMDb dot word index, did I define the IMDb or not? It should be there. IMDb. Okay guys, just a second, let me check whether I have imported the IMDb or not. Okay guys, so here I define the IMDb. Actually I forgot to import that from the data set itself. So once I define the IMDb, here you can see we are able to decode the sentence. Likewise, you can decode any sentence, means you can get the actual word of it. Okay, now there is a couple of basically here you can see reverse word index 0, 1, 2, 3 and all. So what it is representing to us, actually it is representing some special word. Okay, so unknown is there, start is there, and is there. Okay, we can specify that and we can assign the specific token number to that. As of now you can forget, just execute this code. Okay, what you will get, guys, so once you will execute this code now, so you will be able to map the exact number with the actual word of it. That's it. So this is the decode review. Here you can see the decode review. Now if I want to save this model after the training, I can save it. Okay, so let me run it, and here the model is going to be saved. So if I'm going to be refresh this one, so left hand side you will find out the model. Now guys, now the actual thing is started. Now let's see whether we will be able to retrain this LSTM model, and let's see whether we can retrain the same LSTM model for the different kind of tasks. Let's say for the text summarization. Okay, so this is going to be very important now. Now first see the retraining part. So what I'm doing after loading this particular model, okay, again I'm going to be retrain it. So for loading, guys, I think you know the command is very simple. So for the retraining, again what I'm doing, I'm taking a same data, but you can take a different data. Okay, so I'm taking a same IMDb data but a different vocabulary size. I'm just taking 1000 vocabulary. Okay, and here you can see the sentence length and all, everything is same, right? But in your case you can take some different data and you can train on it. Now let me execute it. So this is done. Now I'm just taking 1000 word from here. Okay, sorry, 1000 sentences, because there is a 25,000 sentence in total in the data set itself. Vocabulary size and the sentence both are different, guys. We are just going to be considered 1000 word for making those sentences. And how many sentences are there? Total 25,000 sentences are there, but on 25,000 sentences we are just taking 1000 sentences this time. So here you can see we are able to take that. Now coming to the next part, so we are going to be load the model. So here the model loading is there. So let me load the model. Okay, now after loading a model, guys, what I will do, so here see model loading is not defined. So let me do one thing. Let me define the load model also over here. I think I missed it while I was loading that. Just a second, guys. Let me do it also. Now I return a load model. I imported this particular statement. Now after that, guys, I'm passing my model name over here, LSTM IMDb model. Okay. So finally, I'm going to be load my model. So I'm keeping it inside this load classification model. Okay. Now what I'm doing, I'm just going to be compile this model again with the optimizer, with the loss function, and there is a matrix. Okay. Now here I'm going to be execute that. Now here see what I'm doing. I'm just going to be retrain again on top of this data which I just loaded, xtrain by train. So this is a retraining. This is the retraining, actually retraining on the same model. So once I will retrain, guys, so what I will get, I will be getting my model with the updated knowledge. Okay, but the thing is, guys, we are using the LSTM model, and LSTM model are not scalable. Means if we are going to be retrained again on some new data set, so there is a chances it might forget to the previous data set, because it is learning. Okay, it is performing a learning on. It is doing that sequence learning only, right? So first of all, we cannot train it on very large sentences, or we cannot even train it very huge amount of data set. Okay, I'll discuss these particular point. So here we are going to be train this particular model on the updated data. Okay, and here what I'm doing, I'm just going to be save my model. So yeah, save model is there. Now after saving it, guys, see, once you will check now here, so you will get two model now. First was the like the normal model, and the second was basically was a retrain model, the updated model. Okay, now my main aim, can we take the same model, okay, the updated model, can we load the same model, and can we retrain again on the different kind of task? Because if you will see the LLM nowadays, so one LLM is able to do every kind of task like classification, summarization, translation, generation, and all. So why this thing was not possible with the LSTM? That's my main aim to teach you. So here what I'm doing, I'm just going to be load the model, this one. Now what I'm doing, guys, while I'm see, now I'm going to be retrain this particular model for the summarization task. So here what I'm doing, I'm just going to be take the same thing, okay, same architecture, because see, if we are talking about the summarization, I shown you for the summarization the architecture would be different. uh so here we were using the, see, for the summarization, guys, this would be the architecture: asynchronous encoder and decoder. And for the text classification, the simple many to one was architecture, many to one architecture was there. So that's why, guys, see, if we want to retrain this model, our model, okay, text classification model for the summarization, so we'll have to add encoder and decoder part. So encoder, basically I'm going to take from the same model, from this updated model. Here you can see input length is there, same. Updated classification, from the updated classification model, so here I'm going to take the a layer, okay, my layer first. If you will check the layer, simply you can call the layer on top of this model. So let me take this model name, and on top of it I can call the layers. Okay, now see the layers. So 0 1 2. So first I'm taking an embedding layer, the same embedding layer, and the same hidden layer also, okay, from the same model. Now I'm creating my encoder, so this is fine. Now for the decoder, guys, the decoder actually will have to create from scratch, okay, because we don't have decoder, because we just have single output in the previous task, right? So this is my decoder. So this is the size of the decoder, some vocabulary size I'm going to be mentioned, and here is our input, embedding, LSTM layer, and see, this is the decoder part of it, and finally I have a decoder layer. Now once I will run it, guys, and see, here is my model which I'm going to be compiled. Okay, now after compiling a model, what I'm doing, I'm just going to be prepare my summarization data. On top of this particular data only, we have to summarize, we have to train our model. So let me run it, and let me show you the input data first, how it looks like. So here is my input data, okay, and this is my input data which I will be passing through the encoder, and here is my decoder data, okay, decoder input data, and here is my decoder target data. Because whenever we talk about this summarization, encoder decoder training, so we do the teacher forcing over here. What is the teacher forcing, guys? Teacher forcing means, here see, this is the architecture, okay, this one, for the summarization, right? So we pass the input data from here, okay, from this particular side, they are watching something like this. Then see, BOS, okay, so here this is the start of sentence, right? So LLS regarding, so this particular data, right, we are passing the decoder also, okay. Means what I'm trying to say over here, this this data is fine. We are passing this, they are watching. Now we are going to be translated, right? Whatever we are going to be generate from here, again we are passing over here. Whatever we are going to be generate over here, we are passing over here. Getting my point? So this is called the teacher forcing while we are going to be train the model. Okay, so this is the like itself is a different concept. We'll learn it sometime whenever I'll discuss the classical NLP playlist and all, but as of now it is not required. So here is my encoder input data, decoder input data. Okay, and this is my like this data, decoder target data, what needs to be generated. Okay, now after that guys, here is my sequence to sequence training. Now let me train this model. See, so my model is getting trained. Now just observe couple of things over here. So what could be your observation over here? See, my training has started. Okay, means that LSTM model, I took one LSTM model. I created one LSTM model from scratch. I took this classification data. I was able to train that. See, here is a model. Okay, LSTM IMDb model, right? Now after that, I loaded this particular model. Okay, and I was able to update the knowledge of this model. That is also fine. Till here, everything is perfect. Now after that, what I did, I want to train the same model on top of the different data. Okay, so I took the layer, the pre-trained layer of that particular model. I created my encoder. Okay, and then decoder I designed from scratch because decoder part was not there. And here, see, I'm able to retrain that. But guys, what is the issue over here? Why this model actually was not basically why this model was not equal to the transformer? Let's try to discuss those things now. Okay, and this is going to be very, very important with respect to your LSTM understanding, that why LSTM was not capable. So here only I can ask you one very simple question. Let's say to this model, the sequence to sequence model which I trained, can I predict the previous task now with that? The text classification same? You will say, Sunny, no, we cannot do it. So using the sequence to sequence model, we can only do the summarization now. We cannot do the text classification. But if you will see the latest LLM now, so there actually with the same model, we can do the text classification, we can do the summarization and all. Okay, because we are able to train those models on a very huge amount of data, the unsupervised pre-training and all. Supervised pre-training is also there, means the fine-tuning and all. And apart from that, guys, the ecosystem, the framework and all also supporting to those models, not to these model. Okay, so in none of the framework you will find out a support of LSTM for that several tasks. No, that kind of code has not been built. If you will look into the bot and all, so several head was introduced for the bot as well, but for classification, but for the tokenizer, but for the NER, but for this, that. HuggingFace has done that. Okay, but for the LSTM, no, because LSTM was not having that potential which can take care of the longer sentences, which can be a memory efficient. Okay, which could be trained on a very huge amount of data in the faster mode and all. No, that was not possible in the LSTM. Okay, and guys, whenever we're talking about the NLP, in NLP actually we have a diversity in the task. Like one task is different to the another task. If you will look in the text classification, where we were predicting the positive and negative, right? But this is completely different to this like this summarization task. Okay, so with the LSTM actually we can do the task specific training. Either we can do for the summarization or we can do for the classification. But one single model universally we cannot train like with this LSTM. Okay, so I mentioned couple of points. So let's try to discuss those points, and within like 2 to 3 minutes, I'll try to like conclude it. So here, let's try to see. So what was the points? Here I mentioned each and everything. The first thing is why not directly fine tune that. Okay, you have seen the task type mismatch. So first task basically it was a classification task. Okay, and the next task basically was a summarization. So both are different. How it could be the possible? And for guys, for this particular task, the architecture also is a mismatch one. Okay, architecture wise, so let's say we are talking about the normal text classification. So there we required the many to one. But if we are talking about the summarization, so there actually we required many to many sequence architecture. So that was also one of the case. I think you can understand this both the point. Please go through with it. So the third part is vocabulary differences. Vocabulary differences means, let's say we have trained on a IMDb data set. Okay, now if we are going to be retrained on a summarization task, guys, just think, I just retrain on a same data set. Okay, I just took a same vocabulary and all, but if the vocabulary is going to be different, in that case the encoder part is also going to be fail. Means encoder has learned something, and if we are passing any other data, okay, while we are retraining, okay, so that's not going to be that's not going to be matched with that encoder data which we have trained earlier. Okay, let's assume, see, we have trained on a IMDb data. The encoded part we took as it is now over there. Okay, and let's say any new data is coming, so that will be a out of vocabulary case now. Getting my point? That was also the issue. Okay, out of vocabulary issue means we haven't trained it for a huge amount of data. We can face the out of vocabulary issue because our encoder was trained on an IMDb data set, but anything is coming from any other data set while we are doing testing, it might fail. Performance objective function, yes. For the classification, there is a category binary cross entropy for the binary classes. Okay, 0 and 1, positive or negative. But for the summarization, guys, there is a cross entropy, means for the sequence itself. So there was so many issues, guys. Okay, now what can be reused from this particular model? The model basically which I already shown you. I think we can only use the encoder weights, but again, it is not a prominent solution for the summarization task as well. Okay, we'll have to take a very huge amount of data, or we'll have to do the task specific training only. We'll have to we might get a wrong output as well if any out of box sentence is coming, because our encoder is trained on very limited data set. If any new data set is coming while we are testing, it might fail. Now, limitation of the traditional RNN. So here you can see traditional RNN LSTM basically. Let's try to discuss this point first, then I'll come to that. So initially, guys, there was no universal language model like we have the GPT and the Mistral, Llama and all. LSTM had to be trained from scratch for the specific task. Okay, that I already told you. Transferability concept means that transfer learning concept was not possible. Okay, ULM fit, that was a research which was introduced along with the transformer itself. There they have used the encoder decoder with the attention. Okay, and inside the encoder decoder they have used the LSTM model. But again, guys, the ULM fit, universal language model fine-tuning paper, was demonstrated as a breakthrough one. They first trained a LSTM based encoder and decoder model on a large modeling. Okay, and the modeling was the translation, right? Now then they fine-tuned this particular model on the text classification. That was a downstream task, text classification, and the result was significantly good. The result was pretty good compared to the normal one. But guys, this was still not a fully generic solution, because even though ULM fit showed a power of pre-training plus fine-tuning, there was a major limitation. LLM based model are computationally inefficient for the larger data. There is a lack of scalability due to the sequential processing. Okay, in transformer actually we have a parallel processing. I will show you in the next class that cannot handle very long sequence or the massive data. Okay, so guys, that's why later on BORD GPT T5 model, which was a transformer based model, replaced LSTM as universal NLP architecture. Means no one is using the LSTM model nowadays because this was the issues. Even though encoder decoder architecture was trained with some language modeling task, but again this was also very successful because we have a different task in NLP. The variety of the task, like classification is there, then generation is there. Okay, generation is there, then summarization is there. Okay, and QA is there, translation is there. Okay, see, fundamental, everything is a generation only. If you will look on a fundamental level, so in every task something is being generated. In classification also one word is being generated, summarization also some summarized sentence is being generated, question answer, normal answer is being generated, translation, some translation part is being generated. Okay, in generation again the sentence itself is being generated. So fundamentally everything is a generated one. But guys, the variety of the task was different, and one model, the LSTM model, was not able to handle this thing. And key insight, guys, here you can see I written some sort of a point. So RNN LSTM model was the task specific, not a scalable. ULM Fit has introduced something, transfer learning NLP, using the LSTM, which was a major breakthrough, but due to the LSTM limitation itself, it could not scale. Okay, it could not become generic. Later on, the universal model, the transformer based model, BERT GPT, was introduced, and here guys, the transformer was having the parallel mechanism. It was trained on a massive data because of the parallel mechanism and all, and they were using something called this one, basically scale, sorry, attention mechanism. Okay, so that was also a major breakthrough inside the transformer, okay, to retain the global context of the data, right? So this was it, guys, for this particular video. I think you understood it very well, why this LSTM was not being used, okay, and why LSTM couldn't be successful, because everything against to this LSTM model compared to the current LLM model, the ecosystem and all, and the task variety and all. And I shown you this part as a practically as well. Now I hope you understood it, you learned something, and I will see you in the next video where we'll discuss the differences between the LSTM and transformer. So until guys, thank you, bye bye, take care. I'll see you in the next video.